Hi everyone, welcome to the next session of Geotechnical Engineering 2 and today's onwards we are going to discussing the new chapter, that is shallow foundations and bearing capacity criteria, and he is the father of soil mechanics. Already we have explained about him in previous lectures. In shallow foundation and bearing capacity, we will discuss what is meant by foundation and what are the different type of shallow foundations and what are the different types of deep foundation, and what is meant by bearing capacity, what are the different types of terminologies for bearing capacity, how the bearing capacity will be determined for different types of foundations. We are going to learning from this chapter, as well as we are learning the one more concept, that is settlement of the structure or settlement of the footing or foundation. After construction of any structure, the underground structure, foundation and footing will may go to shear or settlement due to condition, various type of conditions of the soil parameters existing in the underground soil. How the settlement and bearing capacity failure will may happening in this various type of construction activities, they will discuss in this chapter. And if you come to this contents of this chapter, the contents are, the first one we are going to discussing about the types of foundations and factors to be considered in their location. What is meant by foundation, what are the different types of foundations that we are going to learning in this present lecture. Next, as well as next, we are going to discussing about the bearing capacity. What is meant by bearing capacity? Bearing is nothing but support of the load, or how it will be to bear the certain amount of load. Next, criteria for determination of bearing capacity. Why should we have to determine the bearing capacity of the soil mass or bearing capacity of the rock, that we are going to discussing in next topic. And next, factors influencing the bearing capacity. Bearing capacity, it is the supporting capacity of the soil or rock. The supporting capacity of the soil or rock, how it will be changing due to different types of factors that we are going to learning. Next one is analytical methods to determine the bearing capacity. In analytical methods, there are different types of analytical methods are available, but we are learning only in this syllabus as Terjagi's theory of bearing capacity as well as IS code method. By using Terjagi's theory and IS code method, how the bearing capacity is determining for different types of footings, that we are going to learning in this chapter. And next, we are having the settlement criteria. If you observe here, safe bearing pressure based on n values, where here n is called as n value, it will be called as a SPT number. This n value will determine the type of the soil for foundation design. What is the bearing capacity of the soil, that we can determine directly by conducting a field experiment, that is nothing but standard penetration test. That standard penetration test in you will get very clearly in our site investigation in the last chapter. And next, allowable bearing pressure, safe bearing capacity and settlement from the plate load test. What is the soil can capable of acting of the load to resist the load without getting any deformation or settlement, that is nothing but allowable bearing pressure that we are going to discussing. Next, safe bearing capacity. How much amount of load you can safely apply to the soil, that also we are going to discussing in the chapter. And settlement from plate load test. After construction of the, before construction of the any structure or any bridge, by conducting the plate load test itself, we can determine the whether the provided footing or foundation will resist the load, or for certain amount of load, how much amount of settlement is acting on the footing, that you are learning from this plate load test. Next, we are having types of foundation settlement and their determination, how settlement is happening in the soil, how we are determining, that we are going to discussing in this content. And last one is allowable settlement of the structure. If you consider different type of structures on different type of soils, either clay soil or sandy soil or cozy friction soil, for these different type of soils, how the settlement will be happening, that also we are going to learning from this chapter. This is a very important chapter and it will be very practical. And if you observe in our any type of multi-story building or any highway buildings or highway roads, highway bridges. For all these type of parameters, they must determine the soil properties. If you consider the any type of large buildings or any type of large structures, compulsory they will conduct the experiment to determine the bearing capacity of the soil, as well as they will find out the settlement of the structure before construction of that particular project. Okay, next, first I will explain about the what is meant by footing. I will explain about the what is meant by footing. Footing, it is the lowest part of the structure which transmits the load from superstructure to the underground soil, and it is directly contact to the foundation and the underground soil. Here the definition what they are giving, first we will explain that and we will try to connect in practical way. Footings are the structural member used to support column and walls and to transmit and distribute their load to the soil in such a way that the load bearing capacity of the soil is not exceeded, excessive settlement, differential settlement, rotation are prevented, and adequate safety against overturning sliding is maintained. That means if you are constructing any type of a structure, in structure we are having two type of structure. First one is the substructure and second one is the superstructure. In superstructure we can see the beams, columns, slab and the floors like that. In substructure there is a possibility of not visible elements, that is nothing but foundation and footing, where this footing and foundation will take the load of superstructure and it will transfer to the underground soil. By fixing this foundation and footing into the underground soil, it can resist the movement or either excessive settlement or any deformations of the soil, the structure what you are keeping below the ground level or below the foundation of the soil mass. That is the definition of the footing. Otherwise, in simply you can say that it is the lowest part of the structure which transfers the load from superstructure to the underground soil. Okay, but I will show the image, I will explain this footing. And if you see here, what is meant by footing? It is the lowest part of the foundation which is constructed to below the ground level in solid surface. Suppose if you observe here, this is the foundation of the soil element, this is the portion what we are having here, this is the footing, and here we are having the superstructure of the building. This is the superstructure of the building. Suppose if you consider here, this is one multi-stored building. In multi-stored building, this is the ground surface. From this ground surface, we are providing the foundation into this soil, and from foundation in bottom we are keeping the footing. This footing, what it will take, it means the load what it is coming from the superstructure to different floors to this foundation, it will transfer to this footing, and footing will further distribute this load to the surrounding this side and the bottom side of the soil. The footing will distribute the load to the surrounding soil. This is the example how the load distribution is occurring in the underground of the soil mass. The footings will be classified into different types, whether straight footing, straight footing, continuous footing, combined footing, okay, mat or raft footing are there. Otherwise, the foundations also will be classified into different types. That is nothing but shallow foundations and deep foundation. What is meant by shallow foundation? What is meant by deep foundation? We'll see. And if you come to this topic, that is nothing but types of foundation. Foundations may be broadly classified into shallow foundation and deep foundation. And next one more in deep foundation, we are having the mat foundation or raft foundation. Footing foundation also we have defined. Foundation, it is the type of the structure which is connecting to the superstructure as well as the footing. Foundation, it is the structural element which is having contact with the superstructure and contact with the underground soil footing or underground structure, that is nothing but the footing. And here footing will transfer the load to the soil mass from footing to the underground soil. Okay, next. And if you see here, foundation may be broadly classified as shallow foundation, deep foundation, mat or raft foundation. What is meant by shallow foundation? We will see first. Shallow foundation means after construction of any type of footing or foundation, if the load transferring to the soil at a shallow depth, then it will be called as a footing. By general term, suppose this is the ground surface. Suppose this is the ground surface. In this ground surface, from this ground surface to in bottom, you are constructing a one column and otherwise one foundation, and this is the depth of this foundation. Suppose from this foundation we are constructing this footing, where this footing having at a shallow depth, that is nothing but depth of foundation or depth of footing. You can say the depth of foundation I am constructing it from the ground surface to a particular depth. The depth may be either 1 meter or 1.5 meter or 2 meter. That foundation, it will be, by general term, it will be called as a shallow foundation. Whereas from ground surface of the soil mass to the, from ground surface to the soil mass, if you are constructing the footing at a deeper depth, if you are constructing the footing at a deeper depth, then it will be called as a deep foundation or deep footing. When you are constructing a structural element underground below at a shallow depth, or you are transferring the load to the soil mass at shallow depth, then it will be called as a shallow foundation. Whereas if you are transferring the load from superstructure to the soil into the deeper strata or deeper depth, then it will be called as a deep foundation. Then it will be called as a deep foundation. Otherwise, from according to Terjagi, he is the father of soil mechanics. He gave one definition for the shallow foundation and definition for the deep foundation. According to Terjagi, a foundation is a type of shallow. A foundation is shallow if its depth is equal to or less than its width. Suppose if you see here, this is the depth of the foundation and this is the width of the foundation B. If this depth of the foundation is less than this width of the foundation, then it will be called as a shallow foundation. That means depth of the foundation df by b will be less than or equal to 1, then it will be called as a shallow foundation. Where df will be, depth of foundation will be less than equal to width of the foundation, it will be called as a shallow foundation. When depth of foundation it will be greater than equal to width of the foundation, then it will be called as a deep foundation or pile foundation. If you observe in this diagram, here the width of foundation is more and depth of foundation is less. If you come to this picture, here the width of foundation or footing is less and the depth of footing or foundation is more. Hence why this we can say as shallow foundation and we can say this is as a deep foundation. Again, this is shallow foundations are classified into different types of footings. Okay, shallow foundations are classified into different types of footings. Shallow foundations also nothing but we can call it as a footing. Deep foundation also you can say that a deep footing or deep foundation. Sometimes the foundation itself will act as a footing. Okay, foundations are classified into, the shallow foundations are classified into spread footing, combined footing, strap footing or strip footing or continuous footing, isolated footing, okay, combined wall footing. These are the different types of footing. The majority of footings we are considering as spread footing, combined footing and strap footing, isolated footing. I will explain about the individual footing and later we will see the diagrams for the different types of footing. If you see here, spread footing are those which spread the superimposed load of wall or column over large area. Spread footing support either column or wall. That means we are having the one column and from this column the load will be distributed or the load will be spread through some structural area of the soil mass and it distributes the load to the underground soil. By this way, if you construct the footing, that it will be called as a spread footing. Next, it may be of the following kinds. Again, spread footing are classified into single footing for a column. Single footing for a column. That means there is a one single column. For this single column, we will construct one single footing. That single footing will distribute the load or will spread the load to the underground surrounding soil mass. in which the loaded area of column has been spread to the larger size through the single spread. The base is generally made up of concrete. Okay, I will show the image first. Okay. Okay, if you see here, these are the examples of footings here, and if you observe here, this is the one type of simple wall footing or spread footing, and if you observe here, this is the concrete block, and this is the one type of wall. From this wall, from superstructure, the load will be coming to this wall, and the wall will distribute the load to this footing, and footing will transfer the load to the surrounding or underground soil. In this way, if you construct the structure, then you will call it as a spread footing or simple wall footing. And I will see the definitions of this. And slope footing for a column. What is meant by slope footing for a column? In this type of footing, concrete base does not have uniform thickness but is made up of slope. That if you observe in our general constructions, the footings we are providing by keeping some angle of inclination, by keeping some slope, we are providing the footing to the particular members, that it will be called as a slope footing. I will show the image. Next, wall footing without a step. That means we are having some type of walls without providing any vertical steps. Directly we are keeping the wall to the footing to resist the load. It consists of concrete base without any steps, inclined masonry wall. There is a one type of wall. Wall directly will rest on the footing, and footing will transfer the load to the underground soil, which is the load acting to the wall. Okay. Next, stepped footing for wall. In stepped footing, it consists of a masonry wall, have stepped footing with concrete base. In stepped footing, there are different types of steps of footing, and from these different types of steps of footing, load will be transferred to the underground footing, and it will be distributed to the surrounding and underground soil. And if you see here we are having one more footing, that is combined footing. That is combined footing. Combined footing, it is the one type of footing when columns we are providing more than two to support that column nodes, and when they are not very close to each other, when overlapping of footing it will may happen. In those conditions, the combined footing will may favor. Again, combined footing will be classified into trapezoidal combined footing and rectangular combined footing. Suppose if you observe here, this is your building plan, and in this building plan, if you are constructing here one column, and if you are constructing here one more column, instead of providing here for isolated footing, what we will do means we will make one combined footing, and we are provide one column here, and we provide one more column here. Okay, when overlapping of the footing it will may happen, or when property line may very closer to the boundary of the building, in that situation we will prefer the combined footing. If you observe in this diagram, this is the width of the footing and this is the length of the footing. Instead of providing two individual footing in the member, instead of providing two individual footing to this column, they provide one combined footing, and in this combined footing they applied the two column loads. This is the one more diagram for the combined footing when periphery line is near the boundary of the soil mass. If you provide here any footing, the footing distribution of the load to the soil it will be different. Hence why by providing this combined footing, we are making two columns and we are distributing the load to the surrounding soil. This is the cross-section diagram for the rectangular footing, and this is the cross-sectional diagram for the trapezoidal footing. That means when the column is near to the property line, in those conditions we will use the combined footing, and this is the rectangular footing. And next, these are the some examples of the different types of footing. And if you see here, sloped column footing. Sloped column footing means, suppose if you are constructing this footing, and due to various type of loading condition or structural requirements or load acting on the column, this sloped footing or stepped footing or stepped wall footing, without stepped footing, we are providing for our requirement. If you see here, this is the footing width and this is the footing length, and in this we are providing the slope to the footing, and from this slope of the footing we are emerging top to the column, and from this column the load will be transferred this footing. And next we are having the simple wall footing. In simple wall footing, there is a one common wall will be thrown to the footing, and here footing will take the load of this wall, and wall will transfer the load to this footing will transfer the load to the surrounding and underground soil. And if you see here, this is the simple column footing or simple isolated footing. In simple column footing or simple isolated footing, just we will keep one regular footing. In that regular footing, we lift up the column to take the load and to transfer it to the underground soil. Next we are having the stepped wall footing. In stepped wall footing, there is a footing and we are creating in a number of steps. By keeping this number of steps, what it will happen is the resistance of the load acting on the footing from the superstructure, it will may increase. Suppose if you are providing a single number of steps, if you are providing one step only, the load carrying capacity of this footing, it will may decrease. Based on the requirement, based on the availability of the soil here, based on the bearing capacity of the soil, the type of footing will may choose. And next, if you see here, stepped column footing. Here we are providing the number of steps. Due to provision of this number of steps to this footing, the load carrying capacity of the structure, it will may increase. These are the images for the different types of footings. And if you see here, these are the one more cross-sectional diagrams how the footing will be constructing into the underground surface. Suppose if you see here, this is your ground surface, and this is the foundation of your building or foundation of the structure, and this is the footing of the soil element. From footing to superstructure, the connecting element what is available here, that it will be called as a foundation. And from foundation to underground soil, the direct contact with the structural member, that it will be called as a footing. And this is the example how the simple footing it will be. Here this is the square footing, and we are providing a footing, and from this footing the column is lifting up. And again, if you see here, rectangular footing. In rectangular footing, we are providing the width of the footing will be more or less than equal to the depth of the, that means length of the footing. This is the example for the rectangular footing, and this is the example for the square footing. We are providing one square circular footing, and in the circular footing we are lifting one column to the central distance of the footing. From this footing to we are lifting the column, and we are applying the load from the superstructure to the underground soil mass. These are the examples, some more examples of the different types of footings. And next, if you observe here, next we are having the strap footing. Okay, next we are having the strap footing. Strap footing, it is a type of footing in which two isolated footings may be combined by one strap beam, may be combined by one strap beam. Suppose if you observe here, this is one individual footing and this is one individual footing. By combining these two individual footing, we are providing one strap. We are providing one strap to connect in the two footings. That it will be called as a strap footing. Due to provision of this strap footing, again the resisting capacity of the both footings it will may increase, and there is a major possibility of unequal settlement of the members or unequal settlement of the footing. Suppose if you are providing the footing, one footing here, and if you are providing the one footing some far away, one more footing, and due to application of the load, the settlement of these two footings based on the availability of the soil, based on the soil condition, the unequal settlement it will may happen. Whereas if you combinedly connecting the two footings by using one strap, the load distribution will simultaneously transfer to the footing. Due to this load distribution simultaneously transferring this section, there is a possibility of uniform settlement into this soil. Due to uniform settlement, there are chances for less failure of the structure or less failuring of the various type of building element. This is the example for the strap footing. Strap footing means it is a type of footing in which two footings are interconnected by one strap beam. Due to provision of the strap beam, the settlement as well as the settlement it will may decrease, and the resistance of this action also will be increasing. These are the different types of how the straps are practically or physically we are inserting or constructing into the field base. And next, if you see here, this is the building. Here, this is the mat foundation or raft foundation. Mat foundation or raft foundation, it is a larger area throughout the area of the building, throughout the area of the house. We are providing the reinforcement into that particular site. Where we are providing raft foundation or mat foundation means where the bearing capacity of the soil is very weak, or there is a chances of unequal settlement of the soil, and when you are constructing the multi-storied buildings, in that situations we will prefer the mat or raft foundation. In mat or raft foundation, what we are doing means we are providing the reinforcement throughout the area of the site. Where the site is available there, from throughout the site we are providing the footing. Based on that footing, where our required size of the columns are available, we will place that columns and we will distribute the load to on the footing. By provision of this mat footing or mat foundation, there are chances of very less settlement, and load carrying capacity of the members also will may increase. This is the one more foundation and a very most important.